Hello guys, welcome back to my channel. And you're watching the third and last part of the series. What is science? Why is science? In this video, I'll cover topics like quantum theory, gravity, time, and I'll try to answer some of the most discussed questions on internet. So watch this video to the end. So guys, our first topic is quantum theory. To know what quantum physics says, we have to study some scientific history. Quantum actually means packet of power. The least amount of power or energy we can use is a quantum. When we transfer power or energy to a target from a source, like photoelectric effect or photosynthesis, we actually transfer packets of energy. Now we will talk about electron again. In my first video of this series, I said that exact position of electrons cannot be determined. That's when Schrödinger equation came to participate in this ridiculous play. We all know about the dual nature of particles. This phenomenon was unknown to the scientists back then. When scientists tried to locate electron by conducting an experiment, this dual nature was exposed. In this experiment, scientists started with the electron gun. There was a sensitive sheet, which is able to respond when quanta of electron touches it. This can probably help us to determine the trajectory of electron. For time variables, we used a high-power stopwatch. And most importantly, one little slit, or you can say a little hole, was kept in the middle of the trajectory. This was to make sure that electrons are passing through a fixed direction. Now, the expected result was, the sensitive sheet will show some points where electrons will hit, but the practical result was quite different. A phenomenon, which is usually known as diffraction, was occurred in the sheet. Diffraction can only be shown by waves. So it appeared that electron is a wave, but the mathematical result was saying that electron is a particle. So, the experiment started again, but with a sensor attached on the slit. This was to detect if something else is passing through the slit. Also, this sensor was able to respond when each electron passes through it. And this result was ridiculous too. The experiment was conducted keeping everything unchanged. So the estimated result was a wave, but the actual result was a particle. The sensitive sheet was showing a single point where all electrons are hitting. So, we had two different results now, wave and particle. This result triggered a massive research and quantum theory developed. We can't discuss the whole theory here, because it's very confusing. Also, the conclusions are hard to explain too. So I'll use a famous quote to summarize the quantum physics. The moon isn't there if you don't see it. We can describe the behavior of light or electron by only this sentence. Just take the previously discussed experiment as an example. During the first experiment, we were watching the flow of electron, which is wave, and during the second experiment, we were watching the electron only, which is a particle. That's how quantum field theory works. The most popular application of quantum physics is a quantum computer. Our traditional analog computers and digital computers, and even the supercomputers, uses the binary number system. In this system, 0 and 1 are the numbers by which our input is programmed. As example, when we order our device to calculate 17 plus 29, the device takes the input as 10,001 plus 11,101, where 10,001 is binary code for 17, and for 29, it's 11,101. The process to determine decimal to binary is as shown here. Now, according to binary summation rules, 0 plus 0 equals 0, 1 plus 0 equals 1, 0 plus 1 equals 1, 1 plus 1 equals 10. So, the binary sum of 17 and 29 is 101,110, which is 46. Now this was the process of our traditional computers for problem solving. It can only work with either 0 or 1 at once. But, as you saw, quantum theory says that anything can be wave and particle at the same time. Decision is yours. So if we use this rule in our computers, we can work with 0 and 1 at the same time, and can obtain maximum number of outcomes in shorter time. Also, increasing the number of bits, which is 0 or 1, increases the computing power of traditional computers linearly, but increasing the number of qubits, which can be 0 or 1 at the same time, increases the computing power of quantum computer exponentially. And we already know that Google developed a quantum computer, Sycamore. That means, we aren't too far from achieving the ultimate nanotech. Well, now we'll talk about time. And we'll see if time is really an illusion. Basically, according to theoretical physics, time is the fourth dimension. Our first three dimensions are x-axis, y-axis, and z-axis. Take a graph sheet. As you go left to right, Your x coordinate increases as you go bottom to top. Y coordinate increases, and as you move your palm from the sheet towards your face. Your z coordinate increases. In any free space, we calculate the position for some object by this three-dimensional coordinate system. But in case of changing in position continuously with time, we take snapshots. Snapshots are like a photo. The situation of the object at a certain time instant is a snapshot. We derive the necessary equations by observing a series of snapshots. It's just like a video. We continuously see the change in the photos or frames one after another, creating a response of motion picture in our brain. As example, this motion picture has 30 frames or pictures changing per second. All these snapshots are arranged one after another on the time axis of four-dimensional coordinate system. So the summary of this little lecture is, time is the fourth dimension on which the change of any object in three dimension depends. You must have heard that time gets affected for heavy objects. But if time is a dimension, then how can it be possible? Getting confused. That means you're actually understanding it. It's not just the time which gets affected by high mass. The space bends too. We call this space-time fabric. It works just like a trampoline. When you put something in a trampoline, it bends down creating a hole. The heavier object you put, the deeper the hole becomes. Just like that, the heavier the celestial body will be, the curvier the fabric will get. The more curvier the space-time fabric will get, the more distance we have to travel through space. And the more distance we travel, the greater the time dilation will be. Here you heard a new term, time dilation. This was the story and reason behind time dilation. Now let's talk about past, present, and future. From now on, we will start to learn how are we living in the past, present, and future at the same time. Imagine one human in Earth, and one alien in a certain planet, are sitting still in a bench. The distance between them is 1 light year. They are living in present as long as they are sitting still. In other words, their snapshots will be in the same points when both of them are stationary. But if the alien starts to walk, the snapshot will change dramatically. If the alien walk with his face towards the human, then their relative speed of light will increase. And as I said in my previous videos, this will allow the alien to see the past of the human. So, the alien is living his present and the human's past at the same time. Again, if the alien walks with his back towards the man, the relative speed of light decreases. This will cause time dilation, and the alien can see the future of the human. And in this case, the alien is living his present and the human's future at the same time. So we saw that any snapshot can snap a moment when past, present, and future is coinciding, which means we are living in past, present, and future at the same time. So we can probably say, time is an illusion. So our time for time is over. So let's talk about gravity. This will be a really short discussion. We believe that Isaac Newton saw an apple falling and discovered gravity. But this is a complete myth. Accidents can trigger innovation but cannot trigger discovery. Newton did a lot of paperwork to understand the free-falling objects, and gravity was discovered. Anyway, the Newtonian definition of gravity is, every object attracts other objects by a force, which is directly proportional to the product of their masses, and inversely proportional to the square of distance between them. The universal gravitational constant is 6.67 multiplied by 10 to the power minus 11 meter cube per kilogram second square. Newton surely gave us the very basic and also very advanced laws of physics. But he was unable to tell the reason behind gravity. Then a clerk from patent office, usually known as Albert Einstein, came to play the game. Einstein said that masses don't attract each other. It's the curvature in space-time fabric which causes gravity. The heavier the object is, the curvier the space-time fabric becomes. And so, gravity generates. Just like the trampoline example. When you put something in any inclined surface, it will follow the direction of fabric in which its energy becomes minimum. This will show us the effects of gravity. Well, as I said, I'll now answer some of the most discussed questions on internet. There are millions of questions, but I selected 5 questions from them. I expect that these questions are the roots of the others. So let's begin. Our first question is, what is universe made of? The answer is, matter, antimatter, and dark matter. Our second question is, what's inside a black hole? Well, black hole is something inside which traditional physics laws stop working. So, we have to predict by calculation what's inside a black hole, by observing it. We can say that its very high density won't allow anything to stay in one piece. So inside a black hole, there are free electron, proton, and neutron. Our third question is, how did life begin? Miller and Urey experiment revealed that life was started by chemical reaction between water, vapor, methane, ammonia, sulfur dioxide, and carbon dioxide, with the help of sunlight. But there are several theories which says that only the reactants are not enough. According to quantum theory, creating the basic substances for life was the most correct result from the reaction. Also, according to physics, entropy or disorder will increase if life generates. As entropy of universe increases continuously, life will become another option to increase it. Our fourth question is, are we alone in the universe? Once mathematicians proposed that there are 10 to the power 90 stars in our galaxy. Let us assume that's true. If half of the stars have at least one planet, then there will be 5 multiplied by 10 to the power 89 planets just in our galaxy. It is illogical to think that every one of the planets does not support life. So the answer is, obviously we are not alone in this universe. And our fifth and last question is, can we live forever? In other words, is immortality achievable? The answer is, yes we can. The food we take have some chemicals which causes death to our skin and tissues. These dead tissues are recovered. But this process brings some changes to our body. We call this aging. If we can stop our aging by removing those chemicals from our food, we can live forever. Well, those were the selected questions. Now at the end of the video, I'll tell you to like, subscribe, and comment your queries. Thanks for watching. Goodbye.